Well, surely the world is physically to be done. But what he means is that it is no longer necessary for me to go to India to get my Tandoori chicken, or it is necessary for me to go to Switzerland to get my Swiss chocolate. Right now, I can go on the web to the University of Washington, which I will do in a moment, and show you a beautiful video about cloud computing. I don't have to go anywhere, literally, because the world is at the distance of my finger. I can go anywhere I want. In a matter of a few seconds, I could be virtually located in places that I've never been. I could see the Alps, I can see the Everest, I could go, I am an average mountaineer, but I can see the Everest and I can stop without having to do the effort of, living without oxygen, all those things. Right? So, we are in a revolution. Just like Christopher Columbus, by that trip, changed the face of the world, the internet is has opened a complete new revolution. We are witnessing a new revolution. And you are the young generation, you need to be happy because it's the future and the future of the future. That's why when I read the book, I said, oh my God, this is unfair. So let's search for food. This afternoon, we were in Dan's steak whatever restaurant, and I had a delicious tuna. I didn't use my laptop because the conversation was in English. But typically, I travel a lot. Just to give you an idea of how much I travel. Last week, I was in Portland. 2 days ago, I was in Phoenix. Today, I'm in El Paso. Sunday, I will be in San Francisco. Then from there, I go to Santiago de Chile. From there, I go to Buenos Aires. From there, I go to Mexico City. From there, I go to Monterrey. And from Monterrey, I go to Houston. We heard some stories about Houston. And from there, I go to beautiful Columbia, South Carolina. I managed the miracle of living in Columbia, South Carolina, and working in San Francisco. How is that possible? It's a miracle. Just as a miracle it was that Rodrigo brought these yo-yos from Google in cooperation with my sister. What happened is I ordered these yo-yos from Google about 1 week ago or something. And I didn't notice how they send these shipments. Well, they do them UPS ground. And they were scheduled to be here today. So they say they would be here anytime from 7 in the morning to 10 p.m. Oh my God, because this is at 3 o'clock. So intercept the driver. So my sister, I get her the tracking number. She intercepted the driver in Canotillo, right? And then got the box and gave it to Rodrigo. Isn't that a miracle? I mean, we are living these miracles every day. And all right, not a big deal. But it's a big deal. This is what's going on everywhere, and we simply take so many things for granted of what's going on. So I want to tell you how this is actually done. So and again, I travel a lot. I go constantly to places, and places that I've never been before, like I was never in Portland before. So, of course, I like to eat well, see my belly? So I like to go to nice restaurants. And in order to get to nice restaurants, what I do is I search, right? So I go and search, and I'm in a nice restaurant, and then I search, and then what happens is that query goes to a little router, and from that router, it goes to the local server in the community of the neighborhood, and from there, it goes to the internet, and from the internet, it goes back to some router, and back to me. Now, we take this for granted. It takes 0.5 seconds to get a search from Google. Have any of you tried to enter the word engineering in Google and see how fast it comes back? It's supposed to be 0.5 or a second or less. Have you seen how many results it brings? Last time I counted, it was about 8 billion. So, how does it do it? Of course, if you know, you will be willing to, right? It's a miracle. It's a miracle. It's a miracle. There's no other way to describe it. So, If I want to search for tandoori chicken in the car, then I simply open my GPS. Then my GPS, which is in my car, goes to a satellite, actually to a system of 3 satellites, where the location of my car is taken every fraction of a second with a precision of 10 meters. And given my location, I can go to a server where they get my location and the location of the thing that I want to look at, for example, a restaurant. And then they can bring back to the server and to the satellites to my car where are those restaurants that serve tandoori chicken. And again, this happens in fractions of a second. So, what is the technology behind this miracle? Of course, we know that all of this has to do with computers. And if you stop to think for a moment, what were the most important 25 scientific and technological achievements of the 21st century? Can anybody name some? Okay, so you said transistors? Yeah, transistors. What? Alternating current? Tesla. So we have 2 transistors, alternating current. I think, am I in the electrical engineering department here? Computers. Genome. Computer, no, that was invented before, right? Yeah. So we have more, come on, more. That's kind of, the extension of the chip. Yeah. Okay. But this is a computer, it's the same thing. And that's all the same. So, distribution of water was an important thing. And so forth. Yeah, so let's think for a moment. There were, whatever. The point, 20th century. The point is that in the 20th century, there were about 25 important scientific and technological discoveries, 3 or 4 of which had to do with computers one way or the other. And many of those that came through, like the genome, were because of computers. So, again, there is a tremendous influence that we have there. And the technology behind that miracle is as follows. There has to be a computing device, and that could be a desktop, laptop, PDA, GPS. My PDA has more power, more computer power, than the PDA P11 that you have here in the 1980s. There has to be some sort of connectivity, Wi-Fi, WiMAX coming soon to many cities near you. There has to be broadband connectivity, and I'm talking about the miracle of getting tandoori chicken, right? There has to be broadband connectivity. There has to be a way to hold all of that monstrosity of information somewhere so that you can get it regardless of where you are, and that is known as cloud computing. At the end, I will present you a video of that. There are dynamic maps facilitated by GPS, Google Maps, Virtual Earth from Microsoft, etc. Now, in terms of hardware, we have a plethora of things. And because I'm in electrical engineering, we know the motherboards that host all of these components. Then we have a CPU that has an arithmetic and logic unit. Then we have a chipset and a ROM that kind of tells the CPU what is there in that motherboard. Then we have memory, of course. We have external storage in forms of disk. The new machines, the new Apple doesn't have hard disk anymore. It has just memory. The new Lenovo X300 doesn't have any hard disk. Just this is flash power. Parallel and serial ports, mouse and keyboard, network interfaces, wireless communication, Bluetooth communication, video cards or monitors, sound cards, game port, etc. This morning, when I was chatting with some of your faculty of computer science, I confessed to them that I still like to put computers together, and I do that about every 6 months or so. So that's why I can go to the list blindly very easily. And I was telling them that I do that so that I can become, in love with the machine. And I was using this analogy of the apples. So if I were to have say, there are 100 people here about it. So I will give each of you an apple. And then I would ask you to learn about your apple as much as possible. Look at it, see the form of the apple, etc. And then I would ask you to return the apple to the box. And then I would ask each of you to recognize your apple. And I would recognize then that only the ones who took care of the assignment will recognize the apple. So that's why I like computers so much that I build them just for the fun of it sometimes. Anyway, so that's part of the miracle, the hardware part. And then, of course, we have software. The logic that you program to make this thing happen. I love the word mechatronica and progralógica in Spanish to be the equivalent of hardware and software. Mechatronica and progralógica. It kind of makes sense. It's more nice. But nonetheless, this is software. So we have, of course, operating system, which is the one that sustains the communication, manages the resources, and so forth of the entire system. This could be Linux, Vista, or Mac OS. We have the kernel, which is sharing the resources. Then we have, on top of that, drivers that actually are the ones that give resources to the system in terms of the language and the architecture that exists for that motherboard and that system. Drivers, by the way, is where most of the bugs in every operating system exist. Then we have a file system where you store information in a file or in flashcards now. Then we have programming languages in which the logic is coded, and he is a great fan of machine language and C and C++. Then we have Java, which makes me feel bad. Then we have C# and Python, which are great languages. So anyway, that's the way in which you write code to make these things happen. And then you have services like network services, protocols, printing services, security services, and so forth. Then you have applications, things like the paqueteros, what do you say paqueteros? Systems integrators put together on top of everything. That's what paqueteros. Sí, no puedo dejar esto. And then we have compilers, linkers that translate from the logic of those programming languages into the bits of the computer, etc. And all of that, the hardware, the software, all of that is what we know as computer science and engineering. And this is what we think people who endeavors into computer science should know. People who want to study computer science, understand computer science and engineering, should know about computer design, algorithms, data structures, know how to program, understand operating systems, services, and applications. This is completely different from computer literacy. Computer literacy is browsing, is writing documents, using spreadsheets for processing, use of packages, etc. So there's a big difference. There is a big need for people who do this, computer science. There's a big need. It's incredible the need that we have for that. So the question is, it is very evident that there is a wave of change coming, as important as it was when Columbus sailed to the West. The question is, who will continue with that journey? And the answer is quite simple. It's just a matter of genetics. It's not going to be my friend Sam. It's not going to be somebody like me or my friends. It's going to be people like you. And there is a very strong reason. Let me tell you why. It's not that I'm getting old and so forth, which I am. But there is something else. Not only you are younger, more energetic, and faster in your thinking, but also you learn in a different way. This is how I learn. And my colleagues who learn with me in my generation, in the 21st century, learn like that in black and white. We don't have color. So we could not see beyond that, literally. Yeah, that's it. So, so we had a teacher who had some information to transfer to us. We kind of memorized it, and then we throw it back at the teacher. And if you were successful, they would reward you. If not, they would, hit you and so forth. And that's how you learn, Corporal punishment has a place in education, after all. But that's how people in the 21st century is learning. Young people, you have seen these kids. I mean, the famous story that a young kid, younger than 20 years, can program any VCR is true. You've seen them playing around with gadgets, experimenting, going into the parks, chatting with people, doing text messaging, etc., etc. They discover things, they understand them, they analyze them, and with that level of understanding, they create something new. Then that which they discover and create new, communicate to other people, then they get it back, and so forth. The cycle continues. So they are learning in a whirlpool of more and more energy. We never had that before. My generation learned in a different way. So if you who have this different mental frame and who are ready to do changes quicker, who can actually be part of this revolution. And I was telling Anne and their colleagues that if Christopher Descartes would be alive, the famous philosopher who said, "Cogito ergo sum," which means I think therefore I exist. In this day, he would say, "Colligio ergo sum," which means I collaborate, therefore I belong. I exist, and I can be part of the revolution. And I feel this is a very powerful paradigm for science, because we live in a total interconnected world. You have seen these devices. You have seen devices on top of your machines that you cannot understand, the TVs, thin clients, gateways, medical devices, industrial automation, etc. Mobile devices today have more computer power than the devices that I played when I was your age. Let me put it this way. You have seen this. All of these cars have GPS. The cars of today are no longer repaired by this mechanic. You take the mechanic to Joe, and Joe is going out of the shop with his greasy clothes, and then he sits in the car, drives it, saying, "Oh, it has this," and then he repairs it, just by listening. Today's car, the Volvo, for example, you have to go to the shop. They will plug in a computer, which will sense all of the data from the car and the history of the car for the last 2 weeks or so, probably 1 month or so. And then based upon that, it will do a diagnosis of the car. And then based upon that, they could do a repair of it. Even in the vehicle, the technology is amazing. Do you know that about 98% of the computing devices being built will not go to a computer? They will be in cars, in airplanes, in all kinds of machines. So only 2% of the computing devices that we build go on computer. What is that telling you? That the miracle is going everywhere. That these machines are spreading throughout the entire world. In Africa, 10% of the population have access to wired telephones. 10%. 75% of the population use wireless. Of course, they use the cheap ones, and they use these very expensive plans. But they're using those wireless phones to transform the economy. We are hearing reports about communities that use telephone wireless, so that the mother of this child who is very sick doesn't have to go to the village to see the doctor is there. She sends, using text messaging, a question to the village asking, "Is the doctor there?" And they say yes, and they say no, and if the doctor is there, then she walks. And that is has a tremendous impact in the life of a child, in the life of a mother, in the life of a community that is very, very poor. They are using it today at max. So even small examples like that, you can see everywhere going on. So what does it mean connecting dots? You know, data comes in many shapes and forms. For the most part, is noise. So you have to apply some energy to that data so that the data transforms into information. And I'm talking information as Sharon described it. Information is the amount of surprise that you have. So you apply energy to this data to obtain information. And then if you apply more energy to information, you get knowledge. And by that I mean, an example that I used to do many years ago is that you have, let's compare motion with this. So velocity is the first derivative of motion, and then the second derivative is acceleration. Right? So probability is the first derivative of knowledge, and then variability of the probabilities gives you the second derivative. So if you apply the second derivative, then you can come to see which are the variables that actually not only have no information but have variability, and through those you can learn more about the models that you have. So you can apply second derivative to information and improve on your knowledge. And connecting dots for me was a complete journey that started with the brain. Not mine, but other brains actually. What happened is I was fascinated by the field of medicine. So when I finished UTEP, I went to the field of studies, which is the Center of the Studies in Mexico City. And I had the great fortune of becoming the apprentice of a great man, a great mentor, Joaquin Molina, who asked me to go to the first 2 years of the medical program. You know, in medicine you have 3 cycles: the basic sciences, the clinical sciences, and then the internships or the services. So I went to the first cycle, and there I was sitting along with the doctors or the medical students, learning physiology, anatomy, chemistry, etc. 10 courses I took. But then actually I liked it. So while I was doing that, I was also going back to the lab where we were building an intensive care unit for the Seguro Social, for the hospital. So one of my legs was in medicine, and the other leg was building chips and devices and so on and so forth. And I just loved it. So much that when UNAM asked around, see the staff, do you have anybody who knows computers? And yes, I am the one. So I got this job of starting the Center for Computation in the School of Medicine. And what I did in those days is I went around to the School of Medicine. There were 70 research groups, 70 plus minus 5. And I learned from them so much. And then went back to my computer and built models of all kinds of things for biochemistry, for physiology, for embryology, you name it. And because of the success that we had, we created a group that became the model for the UNAM, and then became, in a way, the model for many other centers that came after that. But the point that I'm trying to make is that I like that kind of work so much that unlike the wife of Macbeth, who had blood in her hands and who didn't like it, I actually enjoyed it. So I enjoyed having blood in my hands. Have you ever seen Macbeth? You know what I'm talking about? Okay. There is this tale, Macbeth, the wife of Macbeth tells Macbeth to go and kill Duncan with a knife. Anyway, so this is a test on literature, my friends. I'm testing you. So I like that a lot, actually. That I was wanting to do it because if you go deep into the brain, there are these 10 to the 10 neurons, 10 billion of them, 10 to the 10, and each of them has several hundred connections or synapses and axons. And the way in which they interconnect is very mysterious. So back in 1950 something, there was this famous paper by Huxley and Hutchings, which described an equation that you could use to model the what is known as the evoked potential of the membranes, so that you can determine the amount of electricity that goes out through the membranes or into the membranes. And that equation, I believe, is that's the representation of the activity, and this and that's a closer look to the membrane, and the equation looks like that. Now, bear in mind, this is a system. So this is a system of electric circuits. So I went back to the days when Pierluisi was teaching electric circuits here in the school, and then I resolved the differential equations. But then the difference is that here you have like a system of 6 matrices, right? There you have to solve that for every millimeter of the cell, and for millions of cells, and for time variations that are limitless. So you cannot do that by hand. Forget it. You have to have a supercomputer for that. So the equation looks like this, and we knew that we could not do it by hand, so we had to get computers. So I decided to become a friend with computers, and that's why that kind of changed my life, because then I was always looking on this quest of studying neurophysiology and knowledge and support, and all of a sudden, through that, I discovered this new world in which I could create my own models and play around with nature, because by the way, mathematics is just the language of nature, so you can play with it and understand nature better. So during those years, I moved more towards what is now known as data mining, and you can see immediately that data mining is a field that is very interdisciplinary. It comes from artificial intelligence, machine learning, statistics, Bayesian networks, and databases. So it was always a theme for me to move around and go into fields that are extremely interdisciplinary. I think it's part of my nature. And I guess the advice would be that everybody in this room is good, better than anybody else at something. For example, what's your name again? David, what is the best thing that you do in your life? What? Other than being here. No, seriously. No, think about it. You do something, everybody, that nobody else does as well as you do. What is that? Are you the best in the world? Yes. Actually, no. Yeah. So this is the question. If he's only the world, he's really good. So how could you test that? Go and enter competitions and see if you are as good as you think you are. Because no. But this actually is a very positive thing. What? Excellent. So he has to think, right? No, but literally, think about it. So, for example, he thinks that he's a very good software developer. So I don't question his ability. But what he has to do is he has to put that into a test. And one way of testing is going and enter competitions, because that will tell him how good he is. And if you pass and become the champion of those competitions, then you were right. You are an absolute champion of this thing. But you will never know until you try. Right? And the same happens with my best of friends. What is your name? Eric. What is what you like to do in life? What is your passion in life? Yeah. No, really. It's a kind of a tough question because it's very personal, right? And you're in front of the people and kind of embarrassing you. But please don't think that way. There is always something that we do better than anybody else. And that something is what characterizes us. And once you find that, you have to first assess yourself where you are vis-a-vis the rest, and then find value of that in the rest of the world so you can become a productive member of the community. This is a very important step. You have to test yourself. You never can say, I am good at this until you test yourself against others. What I see coming into the future. I see coming into the future, and we talked about it in this meeting. By the way, how much time do I have? 20 minutes. So I see multi-core systems, new architectures. I see HPC coming very strongly, but in the way of cloud computing. I see social networks. You will implement the social networks so that the other guys in the other buildings can understand and use computers. I see a lot of embedded computing going on, sensoring information, computer appliances, and so forth. I wanted to give you an example of A2C. You probably have seen this data. Have you seen this data? Are you familiar with this data? So this is not very recent. It's circa 2005. In essence, what it says is there are about 135,000 systems that have probably 50K cost, and they have like, I don't know how many processors, probably, I don't know, whatever, 128. Then there are about 22,000 systems that are between 50K to 250K that have probably 2,000 nodes. Then we have about 4,000 systems that have probably between 2,000 to 2,000 nodes, and just a few that have huge number of nodes, like the ones in Oak Ridge, the ones in the area of Texas, the supercomputer center in San Diego, and so on and so forth. So what is going on is that when you see the way supercomputers were built and how much they cost, there's a tremendous exponential decay in cost and increase in capabilities. So look at this number, the number of gigaflops. In 1991, a Cray computer was capable of doing 10 gigaflops, and it was about 40 million. A few years later, the 10 gigaflops cost 501 million. 2005, 10 gigaflops was about 4,000. Keep those numbers in mind. Look at this. This came from Wired Magazine 2007. And this is about the tera thing. Terabyte, terawatt, teradollar, teraflop. Look at this slide carefully. Look at it so carefully that I will make it bigger. There you go. So 1 teraflop is equal to 10,000 of those trays, 1,000, 36%, etc. 1. $0.56 $400. So one friend, Frank Miller, was smart. I said, I like to build computers, and this guy likes to build computers too. So he went Sunday afternoon shopping to Best Buy in Raleigh, and he said, "Man, give me 6 of those babies," and he built a supercomputer for a few, like $2,000. PlayStation. Just for the fun. So, actually 8 PlayStations. So, I was in Mexico City in November of last year when Anne and I first got in touch. And I was trying to tell my colleagues at this staff, don't buy more of those machines, build them! Because they don't cost, they are paying hundreds of thousands of dollars for this, and they can build them if they are actually interested in doing this. So that's one of the things that I see very strongly. Because science in the 21st century is going to be about processing gigantic data sets. Gigantic data sets. Some of the colleagues in the department were talking about climatic systems. They can tell you that they probably will have gigabytes, terabytes of data, petabytes of data coming. So you need to have these kinds of systems so that you can do these kinds of computations that are coming. Also, you need to be the glue that agglutinates the other sciences. You are precious because your expertise can help the biologists, the physicists, the chemists to solve these Schrödinger equations or whatever they are doing for nanotechnology, which is the technology of the century, nanotechnology. You have to read the book by Tony Hay called Quantum Universe. You have to read that book. Because that book, in the first part, talks about quantum mechanics in a very nice way. in a way that anybody can understand it. The second part talks about how quantum mechanics is being used to actually describe and do advances in nanoelectronics. And Tony feels that the new way of change, besides the internet, is nanotechnology via the integral design of quantum electronics. That brings me to cloud computing, and I don't know how many of you have seen this Business Week front page in December. This is Christoph De Siglia, a student of the University of Washington, who is now working at Google. Well, what happens is the traditional way of doing parallel computing was that you get these 1,000 processors or whatever, and then there is a language called the MPI that you have to become an expert of, and then once you understand this system after so many months of doing it, then you go and engage with the community that needs that kind of experience, and work with them in trializing code that can run in many processors. My son went through that, and he liked it, but he said it was very time consuming. So what is the difference here? The difference is that in cloud computing, you write your algorithm in Java or in Python, and then you can download the cloud computing, the MapReduce APIs into a laptop, and then work with, say, small data sets, 400,000, 500,000, and then ensure that the algorithm actually works. And once you know that the algorithm actually works, then you insert about 5 lines of code into the algorithm in which you create what is known as a MapReduce environment, where you have a collection of machines doing the mapping, a collection of machines doing the reducing, and then simply run the algorithm with those 5 lines inserted, and then just go and take your coffee or whatever, and come back a few hours later. So Google runs, 100,000 processes a day of different kinds of computation. And the way they do this is because they came to the conclusion that it was not so much important to have computer power and pay for it. Computers have become a resource that you can throw away. So they have clusters, gigantic clusters of hundreds of thousands of computers, and they get the cheapest possible system that they can. When that happens, then of course there is a high probability that some of those machines will die in the middle of computation. So what they do is they create a system that is very reliable, so that even if the system is running these computations and say 500 machines die during the computation, no matter. The system continues, they find the machines, and continue with the processing. Because it's more expensive the time of the programmer to the time of the machine. So in a way, it's kind of going back to the Matrix movie, where the machines are being replaced by humans. This is kind of true. Doesn't get the error, or probably right, or both. So with that, do we have time for questions? No questions? I keep them. Yes, please. The question is, do I think data mining is mature enough so that we know pretty well which algorithms to use for what kind of problem? Yes, for the most, I would say that for the most part, you can solve 80% of the problems with the known algorithms that you have. If you know how to manage them in order to smart. There are these 10% that we still need to do research. We can guarantee that we get very good results, not perfect results. Next one, thank you. So, are you a professor? Okay, thank you. Okay, another question? If you don't ask me questions, you don't get these things, and I assume you like to play yo-yo. Yes? Yes. Yes. That was my experience. Yeah, well, basically, this happened to me in the reverse order of things. Oh, that's my. See, turn the microphone off. That happened. What happens is, yeah. What happens is, I was too young. I was like 27, 28 years old, and all of a sudden I became the advisor to the secretary in IT, and that was a lot of responsibility. And I saw a lot of things that I did not want to see, and I felt that the person who I was, would not have the right to tell people what to do and how to do it. Particularly people who were older than me, people who had been in certain offices in government for many years, and so on and so forth. So I felt that now the problem is that you have, in Mexico, you probably know the politics of Mexico, you follow your boss legally, and you cannot tell your boss no when he asks you to join him. So in my case, that was a terrible, terrible predicament, because I had to tell the Secretary of Health, no, thank you. So I asked this question before. For those of you who have seen the movie, the Usual Suspects, so there is this line where this guy says, how do you shoot the devil in the back? What did you miss? So 2 years or 3 years before, I wanted to do my PhD, and they asked me, no, stay, we need you, don't go, you are, gold. So when I got into that position, I said, I don't want to be here anymore, and the only way I can actually sort of get out of it is, I want to, you remember? I want to do my PhD now. Oh yeah, of course I remember. Go. Oh, thank you. That's how it happened. It's very strange, because typically you go into those positions when you're older. And then, so I'm doing what I was supposed to be doing when I was 20-something. And when I was 20-something, I was doing what I was supposed to be doing now. Everything in my life is like that, reverse story. Which would bring me to inverted indexes, a wonderful lookup table technique, but that's computer science for another topic. I will give you this for you right here. Yes? Yes. Okay. So the question is, I said Google does a lot of cloud computing. What kind of projects involve that? Well, let me tell you how Google operates, and that will give you an idea of how it works. I think that's a better answer to the question. So Google, what they do is they go through this interview process that is extremely, extremely difficult. We saw some statistics about how many people pass through the interviews, and it's very, very small, because they ask you very, very tough questions. You have to be really good in mathematics, very good in mathematics, and very good in mathematics. And also you have to know how to think, very odd questions, and how to be able to understand the whole picture. And as Christoph said, you have to know how to think in large scale. So they typically hire these incredibly good people, and they bring them together. And then they have a mandate of the 20% time. So every engineer at Google is required to spend 20% of his time thinking of something out of the box. And that happens all the time. When you go to the dining rooms, that's going on all the time. So you see these bright minds thinking about, crazy things. And literally, they get an idea, they start working on it, and then Larry and Sergey are these guys who have no entourage. They walk around everybody. So when somebody grabs them and explains the idea, if the idea makes sense, they continue. If it doesn't make sense, they're not probably not think about it more or whatever. So once the idea becomes a better prototype, it is presented. And if the idea is something that has some potential, then it is like Colin Powell said, you break it, you own it. In this case, you thought of it, you own it. And then they become the leaders and they gather bright people around them to continue. So how many projects? Probably hundreds. Which is completely different to other companies. Yes. Sorry? No, I'm funded by Google. Yeah. Oh, I don't understand the question. Oh, Google. No, Google, no. It's always, no. No, Google doesn't get any money, as far as I know, from the federal government. I mean, probably have some contracts here and there about installing search engines to spy on us. No, nothing of that kind. No, not so. No. It's a mantra at Google. Don't be evil. It's a very strong mantra. You will not. I mean, you have been there, right? It's a very strong mantra. People want to be right there. It's a very strong mantra. I have two more. Ah, yeah. So this is how you. Oh, see that? Well, you will fight for this, okay? Yes. No. So I'm going to repeat the question. Do you think it's important to be a good professional in data mining, or is it good to be, or is it better to be good in something that is your calling? It's a very tough question because it's a very personal question, and I am kind of a feeling the way he felt when I asked him that question. I think that you know what qualities you have in terms of your intellect, right? And you know what kind of algorithms, ideas play better in your head with you. So what I would encourage you is to take risks, to go and find that which makes you better than other people around you, and then learn very well how to do that with whatever it is, and then share it with others, and then learn from them and teach them what you know, because when you teach, you learn more. And don't be confined to any discipline. Data mining is fun, it's a lot of fun, but information retrieval is also fun. Shakespeare is fun. Go and read Macbeth, it's a wonderful story, and then you will know what I'm talking about, the blood in the hands. We are lifelong learners. When you die, you will not take your fortune with you, you will take your knowledge. And the only thing that will stop with your life is your quest for knowledge. You can leave your inheritance to your children, but the knowledge is what you keep and you take. Learn is the best thing that happened to human beings, I think. And whatever it is, just become a jewel that you can be. I don't know if this is very, sounds like, like a politician talking, but a little demagogic, but I'm totally convinced that learning is the most fun that you can have in your life. This is for you. Thank you. Yes? Ethics. Okay. Google has Windsurf. Do you know Windsurf? Do you know who Windsurf is? Windsurf is credited. Oh, do I have to be there? Okay, so we are done. So now we can speak with all the people from Puerto Rico? Cool. So Windsurf is the person who is credited with creating the internet. And he works in the Washington office of Google in issues of policy and standards. So he's an icon of ethics in computing. And Google follows his advice on everything that he has to say. And with regards to China, Google operates within the confines of a government. And they have to obey the laws of the government that you operate. You cannot go to China and drive in the wrong lane. Because even though you like to ride on the right, if you ride on the left, you have to ride on the left. But whenever issues of privacy come in, Google tries to, follow the law, but also make the Chinese government aware that other nations see that as an